Howdy, I'm James and welcome to the iEMSL. When you're working with radio frequency or RF in the lab, you'll need to connect machines and equipment to each other. At these higher frequencies, it becomes necessary to use coaxial cables instead of regular wires. Now, if you look at the equipment in the lab, you'll notice that there are a lot of different connector types, shapes, and sizes. All these different connector types might seem confusing, but today we're going to demystify the amazing world of coaxial connectors. What we have are two conductors, except one conductor's actually inside the other. Since they share a center axis, that's why we call them coaxial, or sometimes coax. In order to prevent the center conductor and the outer conductor from making direct contact with each other, there's some sort of dielectric, or insulator, between the two. The type of dielectric material, along with the physical size dimensions of the inner and outer conductor, are what determine the maximum frequency that the conductor can handle. So yeah, each type of coaxial connector has a maximum frequency. What that means is that if you try to use a higher frequency with that connector, your measurement will suffer from phase instability and also higher loss. In order to know the maximum frequency of a certain connector, you'll need to know what type of connector you have in the first place. And in the iEMSL, we mainly use 7 different types of connectors. The first type you might already be familiar with. This is a BNC connector. Now, this type of connector is often found on oscilloscopes, even some power supplies. For BNC connectors, you can expect reliable measurements and signals up to 4 gigahertz. And you can visually identify a BNC connector quite easily because it uses a twist and snap design with interlocking studs and slots. Here, you can see that the male BNC connector has this spinny bit on it, while the female connector has 2 little lugs on the outside. To make a connection between a male and female BNC connector, push the 2 connectors together such that the studs on the female connector go into the slots on the male connector. Twist the male connector in a clockwise direction until the connector snaps in place. Now, I've been talking about male and female connectors for a little bit, but how do you actually know if a connector is male or female? All you have to do is look at the center conductor. If the center conductor is solid or looks like a pin, that means it's male. And if the center conductor is hollow, then the connector's female. The key takeaway is that regardless of the overall shape of the connector, the center conductor is what determines whether it's male or female. For example, this is a male and this is a female type N connector. Now you'll notice that the type N connector is a lot larger than the BNC connector. Originally developed for use in the military, this large and heavy-duty connector is still widely used today for RF applications up to 11 gigahertz. As before, the type N connector has an outside part that spins freely, while the female connector does not. When connecting 2 type N connectors, spin the outside part of the male connector, which brings the 2 connectors together. Now, this outside part is called the coupling nut, and sometimes referred to as the nut or the collar. The connection is made when it's as tight as you can get it by hand. In the iEMSL, we do not recommend using tools like a wrench to tighten type N or BNC connectors, but we'll get to that a little later. Now, the most common type of connector you'll see in the lab is an SMA connector. SMA is very easily identified because it contains a solid, usually white colored dielectric made out of PTFE plastic, also known as Teflon. SMA is a versatile, rugged, and low-cost connector that works up to 18 gigahertz. Now, when you look at a male SMA connector, you'll see that the coupling nut is hexagonal, where you could easily put a 5/16 inch or an 8mm wrench on it. From the outside, it looks almost the same as our next connector type called the 3.5mm. The 3.5mm connector can go all the way up to 26.5 gigahertz. Now, you'll notice when you look inside this connector, there seems to be no dielectric material. And that's because at these higher frequencies, we now use air as a dielectric between the inner and outer conductor. The same is true for the 2.92mm connector, which we sometimes just call 2.9mm. The 2.9mm connector goes to an even higher frequency, all the way up to 40 gigahertz. The last 2 connectors that we'll look at are the 2.4mm and the 1.85mm. These connectors can go all the way up to 50 gigahertz and 67 gigahertz. You might notice a trend with these connectors, which is that the conductors inside just keep getting smaller somehow. And that's precisely why they're able to get up to these higher frequencies. You might be wondering what the size is when I say 1.85mm or 2.4mm, and this refers to the inside diameter of the outer conductor. Those are the 7 different connectors that we use in the iEMSL. You're probably wondering how we go about making all these connections. And if not, I'm going to tell you anyway. When you look at the connectors like the BNC and type N, it's pretty obvious that these 2 types of connectors aren't compatible, meaning they won't connect to each other. If you want to connect type N to BNC, you'll need an adapter. Furthermore, the gender of your connections needs to be correct. You can only connect male and female connectors together. If you find yourself trying to connect a male connector to another male connector, for example, you'll have to use an adapter that is female on both ends to make this connection. Now, let's take a look at all the coaxial connectors that have this hexagonal coupling nut on them. Although they all seem to have the same overall size, we can't connect them willy-nilly to each other. There are 2 compatibility groups here, which I'll call low frequency and high frequency. The low frequency connectors are SMA, 3.5, and 2.92 millimeter. In a pinch, you can connect all of these components to each other as long as you have the correct gender of connectors. In the high frequency group, 1.85 and 2.4 millimeter connectors will mate with each other as well. However, you cannot go from a connector in the low frequency group to the high frequency group even if you have the correct genders. You'll also need to keep in mind that if you're using different connector types, the maximum frequency you'll be able to reliably measure will depend on the lowest frequency component that you're using. For example, if I connect this 2.4 millimeter cable to a 1.85 millimeter cable, the highest frequency that I can reliably measure is limited to 50 gigahertz, which is the maximum frequency of my 2.4 millimeter cable, even though I have a 1.85 millimeter cable. This isn't just true for cables, but also for adapters and equipment. If I were to put this 2.92 millimeter cable, which goes up to 40 gigahertz on the PNAX, which uses 3.5 millimeter, I'm still going to be limited to 26.5 gigahertz. A loose connection can absolutely ruin your measurements and tests, and this becomes more pronounced the higher in frequency that you go. So in order to ensure a proper and tight connection between your 2 connectors, you'll need to make sure that you tighten, but not over-tighten the coupling nut to the correct torque. 3.5, 2.9, 2.4, and 1.85 millimeter connectors all have a torque specification of 8 inch-pounds, and you can use one of these torque wrenches to make sure that your connections are tightened to spec. Once your connection is hand tight, use the torque wrench to continue to tighten the coupling nut until the handle breaks away. In order to hold the other connector stationary, you may want to use an open-ended box wrench to provide counter torque. When it comes to making connections between any set of connectors, the only thing that spins is the coupling nut. Now, this is incredibly important because if you try to spin the entire connector, you'll end up causing damage to the conductors inside. In the iEMSL, we have some rules about coaxial connectors. First, before connecting anything to lab equipment, take 1 second to just look inside the connector. Check for any damage to the center conductors or any dirt or debris that might be inside. Also, this is the perfect time to make sure you have the right genders for the connection that you're making. Now, if you see dirt or damage in the connector, stop immediately and do not attempt to make the connection. A damaged connector can damage everything that it connects to. Notify one of the iEMSL staff members and we'll help you clean your connectors if needed. Second, never try to force a connection that doesn't seem to be going very easily. Encountering resistance when tightening a connection usually means that you're damaging something. These connectors can be hundreds and sometimes thousands of dollars, so take your time and go slow. If you have any doubts about one of your connections, let us know and we'll be happy to help you. Third, use dust caps to protect the connectors on lab equipment. This is the easiest and best way to keep those connectors in pristine condition, so your measurements are as accurate and reliable as possible. Lastly, lab users will need to bring their own cables for measurements above 18 gigahertz. That includes 3.5, 2.92, 2.4, and 1.85 millimeter connectors. This goes for cables, adapters, and any other accessories you plan on using for your measurements. If you're purchasing or procuring connectors for an upcoming experiment, we can help you find the right types of cables and adapters that will suit your frequency needs and budget. Now, we've covered a lot, and trying to remember all the different connector types, sizes, and frequencies is definitely no easy feat. And that's why we've created reference sheets that you can use to help you remember and identify the connectors you might come across in the lab. You'll find these guides in several places in the iEMSL, as well as a downloadable PDF version on our website and Canvas community. If you have any questions or issues when it comes to coaxial connectors, please don't hesitate to reach out to any of the iEMSL staff. You can find out more information on our website at iemsl.engr.tamu.edu. Thanks for watching, and I'll see you around.